Hello guys, welcome back to my YouTube channel. My name is Adepoja Imde Samuel, but I'm popularly known as Dr. Sami. So today we'll be doing electric charges. So now electricity has two types of charges, which is positive and negative charge. So now let me show you how electric charge, the positive charge, let me show you how it behaves. That is, the electric charge, electric field around a positive charge is this. So let's say we have a positive charge. The electric field around it moves outward, moves outward. Now, if you have a negative charge, the electric field around it moves inward. Are we together? So this is positive charge, negative charge. Now you have heard the word that unlike charge attracts and like charge repel. Why? Because now look at this positive, look at this negative charge. They are unlike charge. This charge is releasing a force. Are we together? And this charge is collecting a force. So therefore, if this release, this will receive. So therefore, it will come together. It will attract to each other. But now, if you're having two positive charge, let's say you're having positive charge, and you know the force around it is going in this direction, is going outward, and you have a negative charge, and you know the force around it is going inward. Sorry, another positive charge. I know the force around it is going outward. Now, since it's going outward. Now, they can't what attract each other because as this one is going outward, this one too is going outward. So they will repel, they will push each other what away. So that's why we say that like charge repel, like charge repels, unlike charge attracts, like charge attracts. So please take note of this that like charge what repels, while unlike charge does what? Unlike charge attracts. So now also there is a value for what? Charge. Now the value for charge is Q. Now this charge, this positive charge can be called proton and this negative charge can be called electron. So this positive charge can be called proton and this negative charge can be called electron. So now there's value for what? For charge. So you should know proton is positively charged and electron is negatively charged. So the value for charge is this. So let's say it is proton that is positively charged. Charge is denoted by the letter Q. So when you see Q, take note that it is what? A charge. So the value for standard value for proton is 1.60 times 10 to the power minus 19 and then the unit is coulomb C. Now the standard charge for electron, which is negative charge, you know Q is charge, so it's negative electron, is still the same value 1.60 times 10 raised to the power minus 19 coulomb. So this positive just shows that it is proton charge, while this negative denotes that it is what? Electron charge. So please take note of this very well. Now for charge to be quantized, for instance, let's say we have a charge Q. So this charge quantization and the quantization. So that's what I'm taking you next. Now for charge to be what? Quantized, let's say we have charge Q is 3 electron. Are we together? Now this charge is what? 3 electron. Now for me to quantize this charge, it means I have to convert it to what? Coulomb. So when you convert electron to coulomb, therefore you have what? Quantize the what? The charge. So we call that charge quantization. So to quantize this 3 electron, it is very simple. Just multiply it with the standard charge times, and you know standard charge for electron is 1.60 times 10 to the power minus 19. So if you multiply the 3 electron with this value, you have what? Quantized the charge. So we call that charge quantization. So 3 times 1.60 becomes 4.8 times 10 raised to the power minus 19 coulomb. So I've successfully what? Quantized this charge. Now how do I dequantize a charge? Now for instance, let's say I'm giving this value 4.8 times 10 raised to the power minus 19. And then I'm asked to look for what? Electrons. Are we together? I'm asked to what? Look for electrons in this charge. So when you hear that you're asked to look for electron in this charge, that is you are asked to what? Dequantize the charge. So therefore, we will do what? Divide this by the what? Standard charge, which is 1.60 times 10 raised by what? My 19 coulomb. Coulomb cancel coulomb. So once I do this, I will have back my 3 electron. Are we together? So this has been the charge has been dequantized here to 3 electron, and this place 3 electron has been quantized to this charge. So quantization is simply multiplying an electron with what? With the standard charge, that is you have quantized it. Then if you what? Convert a charge to an electron by dividing by the standard charge, that is you have dequantized the what? The charge. So that's simply what? Charge quantization and charge dequantization. Now, actually, you know that we say that like charge what attracts, while unlike charge what repels. So now, therefore, there is a man called Coulombs. He studies the force. You know when something repel or comes together, that is when something is pulled away or pulled together. Are we together? There is a force in action. So Coulomb studies the force in actions that leads to what? Two charge repelling and then two charge what? Attracting each other. So let's say we have two charge. Okay, let's say we have two charge with distance r. So this charge 1, Q1, and this other charge. Now, this is what happened to this charge. Please take note. Now, this Q1 attracts this one. Are we together? So there's force of attraction, this force of attraction from Q1. And Q2 attracts Q1. So therefore, Q1 attracts what? Q2 is coming this way. And Q2 attracts Q1 and then is attracted this way. You know, this is unlike charge, you know they will attract. So that's why they're attracting each other. So please take note of this. So the formula of the force that is attracting each other, denoted by coulombs, is F equals to the product of the two charges Q1, Q2, and a constant introduced because of proportionality over r square. So now what this means is that if the distance increase at a large length, the what? The force will do what? Will decrease, because the force is inversely proportional to the what? To the distance. And then if the distance decrease, the force of attraction will do what? Will increase. That's just it. Please take note of this. And then now there's also another thing to take note of. Now this first charge attract this. So this first charge is exerting the force of this on this. So we call the force this first charge is attracting on this, which is in this direction. We call it F12. And we call the force, you know, this charge attract this. So the force of attraction this charge is exerting on this, we call this what? F21. So the force of attraction this second charge is attracting on first one is F21, and the force of attraction this charge is exerting on this one is F12. So it's going this way and this one is attracting it this way. So that's just that. So now what can we study from this? What we can study is that these two charge, the attraction they are having on each other is equal, but it's what? It's in different direction. So therefore we can say that F, you know, this is going positively, so therefore F21 equals to negative, this is going in the negative direction, negative F12. So therefore we can calculate net force. So therefore you should know that the F net can now be F21 plus F12. So this is the what? This is the net force. So this is the formula for the F net, that is the net force of attractions that is occurring here. And this is the what? This is the relationship between the force of attraction the charge is exerting on each other, and this is the Coulomb's law to calculate the force of attraction the child is exerting on each other. Now let's apply what we have learned to answering this question. What is the magnitude of the electrostatic force between a singly charged sodium ion Na plus and an adjacent singly charged chlorine ion chlorine minus in a crystal salt if their separation is 2.82 times 10 raised power minus 10 meter? Now solving this is very easy. Solution. So how do we go about solving this problem? Now we are given a singly charged sodium ion which is positive. So therefore you should know the positive charge of sodium plus Q is 1.60 times 10 raised power minus 19 coulomb. That's the standard charge for any element or material. Now the standard charge for any negative element or material is still same thing, 1.60 times 10 raised power minus 19 coulomb. Now we are asked to calculate the force, which is F, we don't know, and we are given distance r equals to 2.82 times 10 raised power minus 10 meter. Now knowing this value, recall that the formula by Coulomb's law that we use in calculating force is F equals to K Q1 Q2 over R square. Now K is a constant and the value of K equals to 8.98 times 10 raised to 9 Newton meter square per coulomb square. So anywhere you see K, you should know the value is 8.98 times 10 raised to 9 meter per square per coulomb square. Or you can say K is, or you can decide to say K equals to 1 over 4 pi E naught. So K is either 1 over 4 pi E naught, or K has the standard value of 8.98 times 10 raised to 9 meter Newton meter square per coulomb square. So this is the standard value for the constant K, or this is the formula for the constant K. So since we know the standard value of the K, since we know the two Q1, Q2, and since we know the distance, we are good to go to calculate the force. So therefore the force of attraction could now be F equals to our K, which is a constant that has the constant value always, which is 8.98 times 10 raised to 9, multiplied by the Q1 is 1.60 times 10 raised to minus 19. Q2 is still the same value, times 10 raised to minus 19, all over distance square, which is r square, and distance is 2.82 times 10 raised to minus 10, then squared. So now continue from where we stop, we have something like F equals to, now let's multiply 8.98 with 1.60 times 1.60. What are we going to have? 8.98 times 1.60 times 1.60. The value is 22.988 times 10. Now actually we have how many 10 here? 1, 2, 3. So you pick one 10 and you add the whole power. So now let's add 9 plus minus 19 plus minus 19. So 9 plus minus 19 plus minus 19. So we have minus 29. So to solve these indices, 10 is per 9, 10 is per minus 9, 10 is per minus 19, you pick one base which is 10 and you add the whole powers, and that's how we arrive at minus 29, which is 10 is per minus 29. Now let's solve this. We have to square each value. Now we have to square this 2.82 square. 2.82. Why are we squaring? Because the square affects everything in the bracket. So 2.82 square is 7.9524 times 10. Now we don't square a power. Instead, this is a power and this is a power. So power multiply power. Power don't square power. So therefore minus 10 times 2 is now minus 20. Now further solving, we say our F equals to, now 22.988 divided by this denominator 7.9524 is 2.89 times 10. Now bring this minus 20 up here according to indices, it become plus. So therefore, we can have minus 29. Once you bring this negative up here, it become plus, so plus 20. So we have f equals to 2.89 times 10. So minus 29 plus 20 will give us what? Minus 9. So therefore, and force is measured in Newton. Our answer is 2.89 times 10 power minus 9 Newton. So this is the force of attraction that exists between these two charges of proton and electron with this distance and this constant. So that's simply how to solve this question. Now on to the second question. Now don't be perplexed by the amount of words this question is carrying. It is also very simple. So now I need to represent this question on a horizontal diagram. So but before doing that, we need to read what our question entails. So now 3-point charge lie along the x-axis. So let me draw the x-axis. Solution. So let's say this x-axis is like this. So the x-axis is like this. Please manage my line. So 3-point charge lie along the x-axis as shown in figure below. The positive charge Q1 is 15 microcoulomb is at x equals to 2 meter. The positive charge Q2 6 microcoulomb is at the origin. So Q2 is at the origin. So therefore Q2 is starting from the beginning, which is 0. So therefore I'll write Q2 being at the origin, and the charge is 6.00 microcoulomb means 6 coulomb. So it's positive. And then Q1 is 15 microcoulomb is at the x 2 meter. The positive charge Q2 6 microcoulomb is at the origin, and the net force acting on Q3 is 0. Now the net force acting on Q3, that is Q3 should be at the middle. So therefore Q1 and Q2 is having net force on Q3 at the middle. So therefore Q1 will be at this ending, which is now 15.0 is still 15 microcoulomb. So therefore at the middle there will be a force which is now what? Q3. So this force also is what? Is positive force. Are we together? So now what are we asked to calculate? Okay, this is 0. The distance is starting from 0, and to this place is what? 2. So the total distance is 0 to 2, which is the total distance is 2. And this is the length of the distance is 2. So now I did the distance of between Q2 and Q3, we can call it R23, and the distance of Q1 and Q3 is R13. So we are asked to look for the x coordinate of Q3. We have to look for distance of Q3. So we have to look for distance of from this place to this place and from this place to this place. Are we together? So now since we know that the total distance is what? The total distance is 2. So we can say R23 plus R13. Can say the total. Let's represent the 2 by R. So we can say the total distance is R. Now we can say something like this. We can just make R13 subject formula. We can say R13 equals to R minus R23. So now that's just that for that. So now actually proceeding, we have to recall something. Now we have to recall that this Q2 is exerting a force on Q3, and the Q1 is exerting a force on Q3, and the total force they exert is, because they counterbalance each other, is 0. So therefore we should know that since they are both positive charge, Q2 we push Q3 away. So to push Q3 away, and Q1 too will push Q3 away. So it should go like this. So Q1 pushes Q3 this way, and Q2 too pushes Q3 this way. So but the both force, so I can call this F23. I can call the force F13. Are we together? So Q1 push Q3, F13. That's the first Q1 exact on Q3. And the first Q2 exact on Q3 is F23. So now you should know that this force is moving in what? Positive direction, and this force is moving to the negative direction. That is, this side is negative, this side is positive. So therefore we can see that since they are equal in magnitude, we can see that F23 is equal to, now since this one is moving to the negative direction, so but we don't need that, so they are equal in magnitude, equals to F13, because they are equal in what? In magnitude, but they are just facing opposite direction. So I can just put this facing negative, this facing the negative direction, this facing the positive direction. So this negative just shows the direction, it does not stand for anything. So now the force, to calculate the force, this Q2 is acting on Q3. Columns gave us the formula, which is K Q. Now the two Q acting here is Q2 and Q3. So it will be KQ2 Q3 over, now the distance is R23, R23 square, equals, I've told you that this minus does not mean anything, it just means the direction. It shows that it's moving in the what? Negative direction. So the force, to calculate the force, is given by Coulomb's formula, which is now K. Now the two quantity, the two charge acting at this is Q1 and Q3. So K Q1 Q3 over, and the distance is R13 square. So according to what? Coulomb's law. No, Coulomb's law says that F equals to K Q1 Q2 over R square. So that's why the two distance is being squared. So proceeding further, what can we do to this? So I'm not putting the minus because the minus does not mean anything, it just signifies the direction in which the force of attraction or repulsion is moving. So now I can cancel KK, Q3 can cancel Q3. So therefore I'm left with Q2 over R23 square equals to Q1 over R13 square. Now recall something, that our R13 is this. So anywhere we see R13, I'll put R minus R23. So therefore my Q2 is now R23 square equals to Q1. So R13 is still this, R minus R23, so R minus R23 square. Are we together? So now actually let's rearrange this. So rearranging this, let's multiply everything through by Q1, the inverse of Q1. So multiplying everything through by inverse of Q1, it will become R23 square times 1 over Q. So let's multiply everything through by inverse of Q2. So it will be 1 over Q2 equals to Q1 multiplied by R minus R23 square times 1 over Q2. Our aim is to arrange everything properly. So therefore, look at this, Q2, we are multiplying by the inverse of Q2. So times 1 over Q2 equals to Q1 over R minus R23 square times 1 over Q2. So multiply through by the inverse of Q2, so that Q2 can cancel Q2. So since Q2 has cancelled Q2, we are left with 1 over R23 square equals to, now we have Q1 over Q2 R minus R23 square. So now we are on the verge of arranging this. So now I've arranged Q1 over Q2. Now let's multiply through by what? This value R minus R23 square. I should multiply through by R minus R23 square. So doing this will have, we'll have 1 over R23 square. So we are multiplying through by this, not the inverse, we are multiplying through by this. So we'll have times r minus r23 square equals to q1 over q2 r minus r23 square times r minus r23 square. Now the reason why we are multiplying through by this is in order for us to eliminate this. So you can see this cancel this. So therefore we are left with q1 over q2 equals to, now 1 times this will be r minus r23 square over r23 square. So q1 over q2 can now become r minus r23 over r23. Now we can factorize the square. So therefore we can now further have q1 over q2 equals to, now we can separate this r23 for the two numerator because it's dividing everything through. So r23 minus r23 over r23. I think we still have square. So therefore we can say q1 over q2 equals to r over r23 minus r23 divided by r23 is 1 square. Now we can square root both sides in order to cancel the square. So square rooting both sides, square will cancel square root. So now we are now left with root q1 over q2 equals to r minus r over r23 r minus 1. So collecting like 10 will have, bring this minus 1 to this place, we have 1 plus root q1 over q2 equals to r over r23. Now we know that the total distance r, we know that the total distance r is 2. You know r, the total distance r2 plus 3, r23 plus r13 is equals to r. So the total distance r, recall the total distance of everything is 2. So therefore we can now say 1 plus root q1 over q2 equals to, now r is what? R is 2 over root r23, sorry. So we can have 1 plus, now root, now what are the two charges value? Now recall the first charge is 15 UC. Now the U stands for an abbreviation 10 raised power minus 6. So anywhere you see U, it is micro and it is 10 raised power minus 6 in value. So therefore Q1 is now 15 times 10 raised power minus 6 over Q2 is now 6 times 10 raised power minus 6, 6 times 10 raised power minus 6 equals to 2 over R23. Now 10, this can cancel this out. We are left with 1 plus, now 15 divided by 6 is what? 15 divided by 6 is 2.5. So square root 2.5. So square root 2.5 we have 1.581 equals to 2 over R23. So now, therefore, we further what? Simplify. Now, further simplifying, we'll have 1 plus 1.581 is, sorry, 1 plus 1.581 is 2.581 equals to 2 over R23. So now we can now cross multiply. To cross multiply, we have 2.581. This will multiply this if you cross multiply, and this will multiply this. So this multiply this, we have R23 equals to 2 times 1 is now 2. So now divide both sides by this value, 2.581 divided by 2.581. So therefore R23 equals to 2 divided by 2.581. So therefore R23 is 0.7748 meter. Now recall that we have gotten our first value. Recall that R13 plus R23 equals to R. And now R13 plus R23 is 0.7748 equals to R is 2. So therefore we can get our R13. Our R13 can now become collecting light in 2. Bring this positive value to the other side to be turned to negative of this value. So minus 0.7748 R13. So 2 minus this. So 2 minus 0.7748 will give us 1.2252 meter. So now these are the two s coordinate value of what? Of charge Q3 we are asked to look for. So thank you for watching my video. Please kindly subscribe for wonderful and interesting lessons like this. Thank you for watching.